We continue our conversation about basic geometric relationships, but this time we will focus on angles. We will bring up a proper way of communicating about your reasoning. Think of an angle, such as the one on this diagram. I can refer to an angle using more than one correct name. I can say that this is angle STA, or that this is angle ATS. I even can name this angle by using just vertex. Angle T. The way we denote angles in geometry is by using curves. Now let's cut this angle through its vertex T and its interior by using array TR, which is a subset of a line. Let's focus on this situation. How many angles do you think exist on this diagram now? There are 3. And to make it easier for everyone to see what we're talking about, we will continue labeling them. The part of a bigger angle that is on top, I will mark with red curves, and the part that is on the bottom, I will mark in blue curves. Please notice that I'm using a different number of curves. That is to make it clear that we cannot say that these 3 angles are congruent. Different measures of angles are marked with different number of curves. Now, at this point, it's important to notice that I should not be referring to any of these angles as angle T, because it becomes very ambiguous. When you say angle T, do you mean angle on top, on the bottom, or you are referring to the entire whole green angle? Once again, when angles are formed by more than 2 rays, 1, 2, 3, we should always use a 3-letter notation to be precise in identifying which of these angles we're talking about. Well, let's continue to clarify that these 2 parts, the one marked in red and the one marked in blue, are stuck together and they sort of make up this largest original angle. We can say this in a common sense way that will determine for us what angle partition actually is. We will say that angle part 1 plus angle part 2 make up the whole angle. If we actually assign numerical or algebraic values to these angles, then we can continue making up our equation and maybe solving it for a given value. So if I'm talking about part angle 1, then it's angle STR. I will add second angle to it, angle ATR, and we'll clarify that the whole angle they formed will be angle STA. I now may complete that expression with an algebraic expression using substitution. Once I find my A, I will be able to go back and complete substitution for every one of the parts individually. This will give me a value of any one of these disguised angles. You just have to be careful rereading the question part of your problems, because they might want you to not just find the variable A value or one of these specific angles. They might want to identify which of these angles is the smallest or the largest. So you always have to remember about your last step of problem solving, rereading the question to make sure that you answered it properly. At this point, it's also important to make a connection between the pieces that you've already learned about the relationships in geometry. There will be some similarities of angle partition with the relationships we've observed in segment partition. There will be some similarities between angle partition and segment bisector, but perhaps there will be more differences here. And this is the time to start wondering how angle bisector relationships would look like, because that is going to be our next video.